There are a lot of valuable instances where we want to combine sets. Maybe we want to see what's in common between the sets, or maybe we want to collect all the things from both sets and put them together. Well, that leads to two basic operations that allow us to then operate on two or more sets and combine them in such a way that we produce one new set. So there are two basic operations, and everything else kind of stems from these. There's something called the set intersection. Now, if you think about the intersection between two streets, well, that's the center, right? That's the portion of where those two streets intersect. If you stand in the intersection, you are in the crossroads of those two. So in terms of sets, it's the overlap between the two sets, just like the intersection is an overlap between two roads. So we use this little symbol, looks like an upside down U. You could read this as A intersection B or A intersect B. And this intersection really just is a placeholder for the word and. Okay, so this is a new set that we want to form out of A and B, and we really just want the set of all elements that are in both A and B. Now, in terms of where that is in this Venn diagram, that's going to be the portion where the two sets overlap. So anything that cohabitates in A and in B, that right there is the intersection between A and B. So this is what we would call A intersection B right there. So whatever elements are in there, those are the ones that we want to extract, or those are the ones that we want to publish. Then we have what's called the union, and that is a right side up U. The union can be thought of as the word or. So you could say A union B, and really what that means is A or B. Now, before you think about the word or, let's define the word or. The word or means just one, just the other, potentially both. Okay, you see a lot of people saying and or, and that is really redundant. It's unnecessary. In the English language, the word or means just one, just the other, both. There are naturally circumstances where it can't be both. Like if I'm going to go out to dinner, I'm going to either go to restaurant A or restaurant B. You probably know that I'm not going to go to both. Though that word or could mean that I could indeed go to both restaurants. Now, by definition, A union B is the set, it's forming a new set of all elements in A only, B only, both A and B. Okay, well, if you think about the logic of this, if you're in A only, that means you are in A and you are not in B. Okay, that's what A only would mean, right? In terms of both sets, you are in A only, meaning you're in A and you are not in B. So you're in B complement. B only would mean that you are in B and you are not in A. Okay, see how easy that is? And then the possibility is that you're in both. I'm going to do these in 3 different colors just to make this really apparent. A only would be just this portion right here. Okay, that does not share anything in common with B. That's only in A. That's what we call A intersected with B complement. Okay, you are in A and you're not in B. Now for the second piece, B only, well, that would be you're inside of B, but you're not inside of A. So you share nothing in common with A. And it's going to be all of this stuff right around here. Perfect. Okay. Let's go ahead and label that as you are in B and you are not in A. Now, by the way, the fact that I'm writing it from right to left doesn't make a difference. You could say B intersection A complement. That's the same thing. It doesn't matter whether I say, hey, I'm wearing a sweater and I'm holding a pen, or I say I'm holding a pen and I'm wearing a sweater. Doesn't make a difference in terms of the logic of that statement. Now, both A and B, that's that third possibility. We have already done that up top. That's going to be this third portion here, right in the center. Okay, so that in A union B involves A intersection B and these two other regions. Okay, and that's what we call A intersection B. Now, if you're wondering what this outside area is, well, that means you're not in A Simultaneously, you're not in B. So outside, you'd call that A complement and B complement. Not in A and not in B. If you read it as an English sentence, it makes a lot more sense than trying to constantly decrypt the symbols, but we do need to know what those symbols stand for. Okay, that's the visualization that we could produce. And just to pack this up here, make sure this is highlighted as well. Okay, so now there's a third operation that we can get involved in, and that is what we call the set difference. But I haven't considered that one of the fundamental operations because the set difference is really an intersection. And it's defined as A minus B, and it does not mean subtraction. It means difference, but it does not mean subtract because the elements in a set may not be numbers. So the set difference between A and B is the set of all elements where that element is in A and it's not in B. So actually this comma right here sometimes is used to replace the word and. So X is in A and X is not in B. Well, that's really nothing new because up here we already defined what that is. For something to be in A and to not be in B, that could be written as A and A intersection B complement. So you could say that A minus B and A intersection B complement are really exactly the same thing. So there's nothing new there at all. So those are the things only in A. Sometimes we only want to know the elements in A. Similarly, if we wanted to know only the things in B, then we would do B minus A. Okay, or the set difference between B and A. I shouldn't say minus. Okay, let's look at an example here. Say we have a set that consists of the elements 1, 2, 3, 4. B consists of 2, 4, 9, 13. C will contain the element 4, and then let's say that here's our universe. Now, we'll represent these elements in a Venn diagram first, just to help us visualize it. But remember that A intersection B is just going to be the set of all elements that are shared in common between A and B. So if we look at those two sets and we carefully inspect them, A contains 1 through 4, B contains 2 and 4, but then it has these two other elements, 9 and 13, that don't coincide with A. So that means A intersection B the only things A and B have in common are the elements 2 and 4. Okay, now that would be this area right here. The elements that they share in common would be 2 and 4. Notice that A, B, and C all contain the elements 2 and 4, and so here is the A circle, the B circle, the C circle, and they all overlap here in the center. So the element 4 would actually go right there. Now notice that that's still in the overlap between A and B, but I put the element 4 strategically so that it also fell into C at the same time. Then the elements in A that are not in B or C would be 1 and 3. The elements in B that are not in, C, notice, just contains the element 4, so there's nothing in these other regions. C doesn't share anything in common with any other set, and C doesn't have any elements that are just in C alone. Right? C only contains that one element shared in common among the three. And inside of B, we also have the elements 9 and 13. And then if you look at the universe, we've accounted for 1, 2, 3, 4, 9, 13, and then we have this element 33. That element 33 is not in any of these other sets, so we could just place it outside of those circles arbitrarily somewhere. Okay, this is just to visualize it. We don't have to draw the Venn diagram for this, but it just makes it a little bit easier to see. Now, A union B is another way of saying A union B. It's the things just in A, that would be 1 and 3. Just in B would be 9 and 13. And then anything that they have in common would be 2 and 4. Now, if you're like, well, why didn't you put those in order? Remember, sets do not require ordering. So if you want to rearrange them, you can, but this set would be the same thing as 1, 2, 3, 4, 9, 13. Okay, A minus B would be the things that are just in A. Remember, this is the same thing as saying A and B not, or A and not B. So that would be the elements 1 and 3. B minus A would be the things in B and not in A. Okay, that would be 9 and 13. And all right, well, here let's incorporate all three sets. The intersection between A, B, and C, well, that's what they all share in common, and that would be the element 4. Okay, now if there's 10 sets and you have an intersection of 10 sets, that would be what's in common among all of those 10 sets.